Writing equations from tables. Today we're going to look at quadratic functions. That's standard 6.3. And you'll recognize our vertex form here, y equals a times the quantity x minus h squared. There's that second power that we know makes it quadratic, plus k. So we talked about the a value in the context of opening up or down. Today we're going to talk about specifically how can we find the a value given the graph and given a table. And hk we know is our vertex. So let's fill that in. So our vertex is hk from our equation. I'm going to leave this for a minute until we look at our graph. So let me slide that up a little bit. So what is the vertex of the graph that you see here? This is what we did in the last unit. So our vertex is 4, -5, and those are our hk values. So when we plug that into our equation up here, we have y equals a, and I'll leave a space for that, x minus my h value, and my h value is 4. Quantity squared, and then plus is in our equation, our k value, which is -5. And remember that when we're adding a negative, you will often just see that as subtract 5, and we'll rewrite that equation in that way. So let's talk about how do we find the a value. So you might notice that this is narrower, this curve is more narrow than it would be for our parent function y equals x squared. What you want to do is you want to go out and up to that next point. So you went out 1 and up 2. This first difference, this first change right here, represents our a value. Normally we would go to the right 1, up 1, and that would be where our curve is. Because we went up 2, our a value is 2. And we'll talk more about that when we're looking at the table. And how we could calculate this is it is our second difference divided by 2. So make sure you have second difference divided by 2, and that this difference right here, this distance up from your vertex, is your a value. And now let's talk about how can we transfer the knowledge that we have about writing equations from graphs to tables, and writing equations from tables. So hopefully this table looks familiar because it represents the points from the graph right up here. So step 1 is always to find the a value from your table, which means we're going to do the change in y and the change in x and confirm that we're dealing with a quadratic function. And then when we look at our second difference, we're going to divide that by 2 to find the a value. So we're going to do the change in x, which all of these are increasing by 1. When we're looking here, this is increasing by 6. And you can see that if you look at a number line, that if you go from 3 to -3, oh, and I'm glad I'm looking at this on a number line. I'm going from 3 to -3. I'm not increasing by 6. I'm decreasing by 6. And if I'm going from -3 to -5, I'm going to the left 2. I'm decreasing by 2. But from -5 back to -3, I'm going to the right 2. So that would be increasing by 2. And going from -3 to +3, I would be increasing by 6. From here, we need to look at the second difference. We know that it is not linear because these values are not the same. Our ratios would not be the same. -6 over 1, -2 over 1, these would all be different values, so it is not linear because I don't have a constant rate of change. And so we start looking at our second difference. So from -6 to -2, From -6 to -2 is going to the right. That's an increase of 4. From -2 to +2 is also an increase of 4, adding 4. And from 2 to 6, you're also increasing by 4. So because our second difference is constant, we have just confirmed that this is a quadratic function. And now we're going to find the a value from our table. That means we're going to take our second difference and divide it by 2. And so that becomes 2. Second difference was 4 divided by 2 gives us 2. That means our a value is going to be 2 for our equation. Now let's take a look at where our turning point is. Our turning point in our table is the part where we went from decreasing to increasing. So the point at which we made change right here and that our graph started turning is 4, -5. Now in our particular case here, we have the graph right up here and we can see the turning point. But if you haven't graphed it and you have only the table, you don't have to graph it. You can look at your change in y to look at what your differences are and look at where it went from increasing to decreasing or from decreasing to increasing. And we see that that ordered pair is 4, -5. So now we know our a value and we know our hk. And remember that turning point is called a vertex. The final step here is to use these values to write our equation. So I always like to have my equation right in front of me so I can just plug in the values. So please take a moment to do that now. These are the components that remain constant as we plug in our values. Our a value is 2, so we plug that in where the a goes. Our h value is 4, so it's x minus h, so it's x minus 4, and then plus k, which is -5. And again, when you're thinking about how you write this, it's mathematically correct to have plus a -5. Some people would put that in parentheses when you have a negative number. But most of the time, as you get more familiar with this, you're going to recognize that adding a -5 is the same thing as subtracting 5. And so you'll see the equation written most often like this. Y equals 2 times the quantity, x minus 4 squared minus 5. And to note that when we look at our, just like we talked about last unit, when h is 4 in the equation, you see subtract 4 because you have an opposite sign here. When k is -5, you still see it as subtract 5 in your equation. So it's opposite for h, it is the same for k.